In this experiment, we're comparing the difference of droplets that they make with 5 substances: water, milk, detergent, methylated spirits, and olive oil, and what sort of drop they make on 5 different materials. We have glass, perspex, a piece of plastic, a sheet of copper, and a waxed sided piece of paper. I'm applying a droplet of water onto each material. What we do again?
No, that's alright. Can't hardly see that one though.
Yeah.
It's spread out everywhere, hasn't it?
Yeah, it's just there.
Just point to it. So
it's just there. That's where the word droplet ended. Just there. The next substance I'll be using is milk.
That's pretty much the same on all of them, isn't it? The milk?
Yep.
The water was different on the plastic and the paper.
Yep. The next substance is detergent.
That's some pretty thick detergent.
Yeah.
Alright, and it just forms gloopy bits on all of them, doesn't it? It spreads out a little bit though, as you can see with this one here on the perspex, and that one there.
The next substance is methylated spirits.
What do you notice with the metho straight away?
It doesn't just...
It spreads, doesn't it, straight away? It's not forming a droplet. What does that tell you about metho?
strips.
The bonds aren't as strong as water in the pipe.
The last substance I'm using is olive oil.
Prediction on olive oil before it goes? Before we do it? What do you think? Do you think for olive oil?
I think it's going to be the same as the milk.
Yep, I think it might form a glob. Let's have a look and see. Does it form a glob? Yep, there's a big glob. Hello.
Can you straighten this out?
Yes, I can. The glass. What can you tell me about the glass, guys?
Most of them are all bubbled up, except for...
Just comparing the different droplets of the milk, the detergent, the olive oil, and water, and the methylated spirits on the glass sheet. The methylated spirits has completely evaporated, except for a little remnants of it. The detergent has stayed and formed a gluggy bubble. The olive oil has again formed a bubble, and same with the milk. The water has also formed a bubble. On the perspex sheet, the methylated spirits hasn't evaporated as fast as on the glass. It's still a bit there. The milk has again formed a bubble, same with the detergent, the olive oil and the water. Going on the plastic sheet, both the water and the methylated spirits have evaporated. Only a little remnants of them remain there. The detergent has formed an air bubble within itself, being surrounded by the detergent. Air bubble has again formed a bubble, and the olive oil has formed a bubble but has spread out.
The milk has formed a bubble again, and on the copper sheet, the detergent is as well a bubble. The olive oil is a bubble as well, and the water is a bubble, and the methylated spirits is nearly evaporated fully. This is on waxed paper. The detergent has formed a bubble as well, like on the perspex. The milk has formed a bubble.
Bubble that has been absorbed.
The olive oil has evaporated nearly and been absorbed.
Methylated spirits is completely evaporated.
Yeah, methylated spirits has completely evaporated, and the water's complete. It's a bubble and it's nearly
So guys, what does that tell you about each of the liquids? What sort of assumptions can we make about those liquids?
The methylated spirits has weak bonds, I think, because it's evaporating on the copper and nearly all of them.
What's the main component of methylated spirits?
Alcohol.
Alcohol. Now, alcohol is the solvent, isn't it?
Yeah.
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 So, does that explain why it might be doing the things it's doing? And explain some of its properties?
So it's absorbed and it's not, the bonds aren't really strong like in the detergent or in the milk, which has kept a bubble in all of them.